All right. Hello, everyone, and hello, YouTube. Um, Welcome to Firmware 105. So, an agenda for today, we will be covering first a recap, then about FSMs, event queues, and project architecture and patterns. So, here's a quick recap of the last lesson. We talked to ICs using the SPI and I2C communication protocols. We have a car-wide CAN bus to communicate between our controllers. You should know what these all stand for, even though that's not very important. And we use code generation in a separate repository to facilitate using CAN and make it nicer to do everything. Right. So we'll first talk about FSMs. So a finite state machine is what it stands for. It is a very useful concept. It helps define system behavior in many different circumstances, and it's not exclusively a programming concept. So you can think of an FSM sort of as a never-ending flowchart. The system is always in one of these states represented by a circle, and it transitions between states when something happens. So insert coin, select option comments in this, I guess, a coffee machine example. So these aren't necessarily a programming concept. Usually you learn about them in your digital circuits or logic class. I know I learned about them in EC 124. Other classes, side 192, MT 262. Anyways, so in this state, FSM, the states are idle, coin inserted, and option selected, and the arrows are transitions. The nice thing about FSMs is that they can be described really succinctly in code. So here's like some pseudocode for how you could describe this FSM. These is coin inserted is whatever functions, they're pseudocode, but hopefully the point is made. You can describe an FSM with like a single state variable to check what state it's in, or like to hold what state we're in, and then a bunch of if-else statements in a while loop to transition between states. An alternative for representing an FSM is a transition table, which describes what all the transitions are. This isn't as pretty as the diagram, but you can turn this into code really easily. So we could go and write all those if-else statements there, but since this is such a common pattern, we actually have a library for it. I'll show you the header, except it's not very useful. It's just a bunch of macros. What is useful is an example on how to use it. So great. So the few macros that are involved here, the library has a bunch of macro magic in it, so it doesn't look very much like typical C code. But anyways, you declare your states with this FSM declare state macro. So this declares 3 states: state off, state drive, state reverse. This is from the MCI drive FSM. So the MCI is the motor controller interface, and keeps track of what state the motors are in. So then you define the transition function with these FSM state transition macros, and then FSM add transition to add a transition between states. So in this case, for example, this one says that the drive state, when we're in the drive state, if we get this MCI drive FSM event off state event, if that event occurs, then we transition to the off state. And then we initialize the state output functions with FSM state init. So a state output function is a function that will be called when we transition to a state. So in this case, this FSM state init, state off, PRV state off output line says that whenever we transition to state off, regardless of what happens, we run this function PRV state off output, and then initialize the whole FSM with FSM in it. So a word about guarded transitions. You see this FSM add guarded transition macro around. It's basically the same thing as FSM add transition, except it only transitions when we receive the event, but also when we receive the event, it checks this function. This function has to return a Boolean, and optionally can take in some context as a parameter. And it's evaluated, and only if it returns true do we transition. Yeah, and the output functions are called only when we successfully transition to it. So I can show you an example. For another example, let's see. I'd like to use the light signal FSM since I wrote it. So this FSM is the goal of it is to hold the state of the state of the lights. So are we signaling left? Are we signaling right? Are we hazard? So we're signaling both. The states here are none, left signal, right. So these are the bunch of states. So none, left, right, signal, hazard, and also hazard left and hazard right, which is for when you can have the hazard lights going, but also turn the stock that defines the left and right signal. So that's for handling that. So then we define the transition function. Don't worry about these lines for now. So for example, if we're in state none, we will transition to the signal left state if the signal left input event comes in and pure V guard on returns true. And all right, so that's another example. Does anyone have any questions about that? Not to do with what the event stuff is, because I'm about to cover that. If you have any questions, you can put them in the chat or unmute yourself. All right, let's move on. So you may have noticed in the previous code example values like this MCI drive FSM event drive state values. So these are what we call events. So a project will generally contain a global event queue, which is used to communicate between modules. So an event queue, well, it's a queue. If you haven't taken data structures and algorithms or need a refresher, a queue is basically an array where you can add on to the rear of it. So you can insert something onto the rear, and you can remove stuff and pop stuff from the front of the queue. So it's a queue you take from the front and insert in the back, also known as a FIFO, first in, first out. So the ways that we interact with the event queue are through these event raise and process event functions. So modules will call event raise priority or just event raise in order to raise an event, and that adds it on to the end of the event queue. And modules will expose a method to process events, like this drive FSM process event function. So usually these functions are called in the main while loop. I'll show you an example. Let's look at Solar's main.c. So you may have seen this super loop, it's actually called, at the end of main functions. So the idea with this is that it just processes all of the events in the event queue over and over. So this event process function will take the highest priority event from the event queue and stick it in this this pointer, and then we pass it to all of the process event functions so that all of the modules in Solar, in this case, can process it. Yeah, so we have to call CAN process event because our CAN library actually uses an FSM internally, which is driven by events, and they use the event queue internally in the CAN module. So events also have a priority, which is one of these, event priority highest through lowest. So it's actually a priority queue if you've taken data structures and algorithms. And so the event with the highest priority will take priority over events that are lower priority, and it'll be processed first. Yep. The event structure, let's see, do I have it in here? No. I'll show you the actual event data structure. Or the, oh, there we are. Okay, so the event structure has two fields: the event ID, which is an integer type deft, and the data is just a uint16 you can use however you want. So yeah, so these, come on, there we are. So these events that you may have seen, these are event IDs. All right. So you declare your events per project. And the important thing to note is that no two events can share the same ID. So that's why we use this technique, setting it to, you can see this is referencing the nummci can events from back here. We do this in order to make sure that no two events share the same ID. So I'll talk about how to use it in FSMs a bit. So FSMs expose this FSM process event function. And usually you call this from a process event function like drive FSM process event, a module level process event function. And that way you can use multiple FSMs in your project without conflicting through this FSM variable. So you use them so then you can use events to trigger FSM state transitions. So if I back up to over here, when, for example, in this example FSM, when an MCI drive state FSM off state event is processed by FSM process event, it will transition if it's in state drive. Yeah. So for a bit of an example of how this is used in MCI, this is how it is used in MCI. So what happens is in MCI center console, which is where we store most of the application state of the whole car, send a CAN message to MCI with the system CAN message drive output, which it receives, and then it maps that some data in it to an event, which it processes, and then and that's how it transitions between. That's how the drive FSM transitions in MCI, if that makes sense. So this over here, the S drive output FSM map is what's called a lookup table. So you check the index of this E drive output thing in order to get an event, and this is a pattern commonly used. So as an aside, exported enums. So this is an aside. Sometimes it's useful when you're talking between projects to have the same definitions for some things. For example, center console telling MCI what state it's supposed to be in. So for this, we use a header file called exported enums. So I'll show you that. Yeah. So all it is a whole bunch of enums, all starting with EE for exported enums, and they're shared between projects because it's in a library. Their indices always start at 0 per enum, so we need to use this lookup table to determine to translate it into the right event for transitioning the FSM and MCI. So if you're adding CAN messages or need to transition, or sorry, if you're adding CAN messages that need to share state among different projects, or CAN messages that have like enum fields that need to be understood among projects, then you should add the exported enums. Right. So in summary, using FSMs and events looks like you define your events, you define your FSM, you define your process event function, you initialize your FSM, and you call your process event function in that big loop in main, and then 5 party emojis. Right. Does anyone have any questions about FSMs or events? All right. Okay, we'll just do the last section. If anyone has any questions, you can say them afterwards. All right, so project architecture. When it comes to solving a problem with code, there are infinitely many solutions, but most of the time we fall into something called a pattern. So for example, the solution to repeating a few lines of code a lot would be to add a function that runs those lines of code. But most of this stuff is super complicated, so we'll just stick to our overarching basic pattern. So in a project with a lot of modules, you can end up with code from one module wanting to access functionality in other modules, and then it can get really messy with code diagrams that look like this. It looks like spaghetti. There's circular dependencies all over the place. And this isn't good, because if you want to change a function, you have to change it in a lot of different places, and you don't have guarantees that the whole thing isn't going to fall apart. Instead, by using events, you can make it look like this, which is good and less ugly. It's much easier to work with, and you can do this with event queues. So here in each module, the only function you need to make public is your process event function. Each module will raise some event. Main calls each function's process event function, that event, and perform the necessary actions. So in that way, instead of like directly calling some other module, you can raise an event, and then that function will be called, or then something will happen in another module when it processes that event. So in practice, it can be more complicated, but in general, we want to minimize module interdependence as much as possible, which also makes modules a lot easier to work on in parallel. So you can have two people working on the same thing at the same time, or many people working on the same project at the same time without running into interference. So that is all. So you have now finished the firmware tutorials. And there's just one bit of homework at the end, and you've learned as much as you need to learn, as much as there is to learn from the firmware 101 through 5 tutorials. So as a recap, I'm not going to read out all of this. This is everything that you've learned since firmware 101. So that's a lot of ground covered. Some of it will be useful in your courses as well. This isn't all for nothing. There's no next tutorial, but if you think of something that you want me to cover, I can put together firmware 106 or 201. There is homework at the end if you want to do it. Usually the rule is just that you do the firmware 102 and 103 homework, and once you've done that, we can give you a task. But if you want to practice with event queues and FSMs, it's there, and I will link it afterwards, as well as these notes. So if anyone has any questions, you can ask them now.
Are events basically used like APIs?
Yeah, sort of. Yeah, sort of. Trying to think of how it's like a good analogy for that. Yeah, it's not like it's just sort of an architectural style to use event queues to drive all of your interaction between modules. So yeah, you could think of it like if you want, you could have a project where each module defines what events it accepts and how those are used. Usually, at its core, the events is just events are just used through the event queue to provide information to all the modules at once, sort of. I don't know if I answered your question. But yeah, I guess you could think of them like that. If anyone has any more questions, put them in the chat.